for this example, it's the same as the one we saw before. It's the pulse rates in beats per minute of 9 students enrolled in Michael Sullivan's introductory statistics course. So if there's 9 students, again, that means that n is equal to 9. That's our sample size, because remember we talked before about how this is a sample. It's not all of his students. He doesn't just have 9 students. And we had all this data in the calculator before, so hopefully you still have it in there. Go to Stat, Edit, and you should still have the data in there from before. If not, pause the video and put it in there. And just like before, we did mean, median, mode, and then I showed you how to get those on the calculator. We're going to do the same thing here. We're going to do range, variance, and standard deviation, and then I'm going to show you with the little square at the bottom of the page how we get these off the calculator. All right, so if we want to do range first, that's a pretty good one to start with. We are going to do the high value minus the low value. Okay, and this is one formula that you really do kind of have to memorize, but I don't think we're asking too much for you to memorize this formula. I mean, come on, in terms of formulas, it's a pretty easy one. So if you look through here, or if you have your data sorted on your calculator, the highest data point is actually 81. And then the lowest data point, it looks like it's 60. So if we subtract those, 81 minus 60, we get 21. So 21 beats per minute. That would be the range. So his students' pulse rates have a range of 21 beats per minute. Now here's the problem. That doesn't tell you like where on the number line that range is. Like if this was a number line, is it 0 through 21? Is that their pulse rates? Or are their pulse rates 20 through 41? Or are their pulse rates 100 to 121? Do you see what I mean by it doesn't tell you where that little range lives on the number line, just that the distance between high and low is 21. So that's where range kind of falls a little short in my opinion. So 21 beats per minute, that's range. But let's talk about standard deviation. That's the one we really want. And we have to go through variance to get to standard deviation. So let me write the formula again that was from the previous page for variance. This is what it said. It was a big kind of scary looking fraction. And it said you take each individual data point, you subtract the mean and you square that amount, and then you end up dividing by n minus 1. Now, if you will recall from the previous example we did in the last section, the sample mean that we found for this data set was 72.2. So let me just write over here. This is 72.2 beats per minute. So we're going to take each of these data points, subtract 72.2, and square it. And we're going to do that all the way down the whole list. And so I went ahead and typed it up so you guys wouldn't have to write so much. So start with the first data point, 76, minus the mean, and then you square it. Plus, do the next one, 60, minus the mean, square it. Next one, 60 minus the mean squared. The next one, 81 minus the mean. Do you see what we're doing here? And this is what I love that we can do in math. You just put plus dot 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 because you get tired of writing or typing. And then we're just going to jump ahead now that you see the pattern to the last one, 73 minus the mean, and we're going to square it. And I already typed all of that in my calculator, and I got a grand total of 529.56. That's what the top of this fraction is. Okay. Now we're going to take that and we're going to divide by n minus 1. So if n is 9, 9 minus 1 is 8. So that's where this 8 is coming from. That's your n minus 1. So take your squared deviations, divide by 8. Let's see what we get. 529.56 divided by 8. And we get 66.195. 529, did I do that right? Divided by 8, yeah. But that's squared beats per minute, and I don't know how to interpret squared beats per minute. So yes, my variance is 66.195 beats per minute squared, but I don't really know what to do with it. So what I'd really like to do is keep talking about beats per minute. So I'm going to square root this answer here. That's why I kept all the decimals. And let's see what we get. Okay, so to square root, you need the square root button, which should be down here about the 5th button down, and it's blue. So second square root, 66.195. And we're going to get 8.136. I don't know, maybe we can call it approximately 8.1 or 8.14 or 136, whatever you want to do. I guess we can say about I'll just say 136 beats per minute. But now we're back down to beats per minute. So we know that the average pulse rate is 72.2, and the amount of variation of each data point on average is about 8 beats per minute. So you could say that most people have a pulse rate that's 72.2, give or take 8 point something beats per minute. Okay, that's what the standard deviation is. All right, so that's how we do it by hand, but I am certainly not expecting you to crank out variance by hand. Again, we can say we've done it. Like I always say, been there, done it, got the t-shirt, we can move on. So now what we want to do is get it off the calculator. So I actually already showed you how to do this. You go to stat, this is how we got the mean and the median. Go over to calculate. I told you your new best friend was 1VAR-STATS, so go to 1VAR-STATS, and we want list 1. That's the default for the calculator. If you have this little menu like I do, you want that frequency list to be blank, and then you go down to calculate. If you have the older calculator where it just says 1VAR-STATS on the screen with no menu, just hit enter because it'll automatically look at list 1. So if we go in here, we can see the mean is 72.2. We knew that from before. And right in here, you see SX and sigma x. So you might say, well, why are there two different ones? S is sample, and I have it down here on the bottom of the page. SX is sample standard deviation. And do you see that it's almost exactly like what we got? Now, why is it off a little bit? From round-off error because of this right here, and because of my 529.56, just a little bit of round-off error. Sigma, that's assuming that these 9 people were the entire population. If you knew they were the population, there's a slight small difference in the formulas. And so you would use sigma x instead. But 9 times out of 10, y'all are going to look at SX. And then it tells you the sample size, tells you the minimum was 60. If you go down here, the maximum's 81. You could use those to get the range. Your calculator does not do range for you. You have to do it yourself. But at least it gives you the min and the max if you had a bunch of data. So you've got min and max to get your range. You've got median. You have the sample size. You have the sample standard deviation, and you have the sample mean. So all the statistics you're going to need in this chapter are going to come right off the calculator. You just have to know where to find them. Now, in the homework, sometimes what they do is they'll ask you for the variance before they ask for the standard deviation. So here's your workaround that you're going to have to do in the homework. You'll notice this does not give you variance because normally we don't talk about variance. But if you were asked for the variance, you would need to write down that the standard deviation off the calculator was 8.135996832. Go ahead and take all of the decimals and write them down. And if you wanted to get the variance, you could take that amount and square it. The reason you want to write it down is because as soon as you start typing, like 8, you saw it went away. So you can't see it anymore. So 8.135996832. Take that number and then you square it. Don't square root it. You want to square it. And that will give you the variance that we had here. See, I had a little bit of round off error just because of the way I did it. But that would be the variance that you would use on MyMathLab. So again, let me say that one more time. If in the homework they ask you for variance before standard deviation, go ahead and get the standard deviation off of your calculator here. take that standard deviation number and square it, and then that will give you the variance. Okay, let's see, what did I have in there? 66.1944444, and then it ended in a 5. And then for the homework, you could round it off however they ask you to round it off. So that's how you're going to get the measures of dispersion off of your calculator. All right. So we talked about resistance before. We found out that the median was more resistant than the mean because the median could handle these extreme values and these outliers. So now I want to know, is the standard deviation resistant? What do you think? If you think about the formula for standard deviation, which involves the mean, it involves using all of the data points and the mean and basically running something similar to an average. Do you think the standard deviation is resistant? The answer is no. Because if you throw in, like I said with my example of ages, if we were all 25 years old and then a 90-year-old walked in the room, that standard deviation formula is going to use that 90-year-old in the calculation, and it's going to go crazy big, right? It's going to think that the spread is huge when really there might just be one person that's 90 and everybody else is 25. So the standard deviation should only be used for data sets that do not have extreme observations. If you don't have any crazy outliers, then go ahead and use standard deviation. Otherwise, if you do have outliers, there's something else you need to use, but we haven't seen that yet. We'll see it in a future section. All right, so let's try this one. The following data represent a sample, so they're both samples, of exam scores in a statistics class taught using traditional lecture and in a stats class taught using a flipped classroom. I think I have a typo in there. And in a stats class using a flipped classroom. Flipped means you do your lectures outside of class and then you come inside a class and do your homework and everything. So it's flipped, what you do in and outside of class. And I just want to know which class has more dispersion in the exam scores. Okay, so what we're going to do, put traditional in list 1, and we're going to do flipped in list 2, and we're going to use the calculator to help us out here. So go to Stat and Edit. We can clear that list, and I'm going to put traditional in list 1. The beauty of videos is if I go a little too fast, you can always pause or back up. And then in list 2, I'm going to put the other one. I'm just double checking to make sure I got them entered correctly. Okay. Traditional, flipped. We want to see which one has more variation or dispersion. I don't care who's got the bigger average. I want to know who has more spread. That's what I'm interested in. Okay, so to get the standard deviation for this sample here for list 1, that's for traditional, we want the calculator to look at list 1. You go Stat, Calculate, 1var stats. You make sure that it says L1. We're going to go down to Calculate. And because it's a sample, we want to look at S. So I'm just going to write out maybe, 3 or 4 digits. 9.5568. And that would be points because these grades are done in points. So that would be how much spread there is in the points, 9.5 points. Now, if I want to do the flipped class, here's how you get your calculator to look at a different list. You go Stat, Calc, 1var stats, but now you need to put L2 so that your calculator will look at L2. And if you have the older calculator, you'll type L2 at the end where it says 1var stats. So I need to put second 2, because remember the L2 is down here. So second 2, and that's going to tell my calculator to look at the second list. And that standard deviation is like 8.9016 or 8.902, whatever you want to call it. I'll go the same number of decimals. 8.9016 points. So who has more variation? Traditional. Traditional has more variation simply because their standard deviation was larger. Also,